So this presentation, this tech talk is about migrating your PySpark code base, say your on-premises to Databricks, okay? Now, conceptually, the premise basically here is on a case-to-case basis, migrating your code base to Databricks makes sense. Okay. For example, somebody, if it's a new organization who's starting new and they want, starting new and they want a scalable compute cluster which they cannot afford or they do not have the real estate for, they can always opt for something like a cloud solution like Databricks, but they might be having a smaller solution on premises, and they might be needing to move their code base over to Databricks, over to the cloud. Okay, that's the premise of this tech talk. Okay, going to the next slide, I will talk about a few advantages of Databricks. So I think most of you are aware of Databricks, right? It's actually a cloud-based solution which is available on, say, AWS and Azure for your computing needs. Okay, and it provides you with a scalable cluster on which you can run your ETL workloads along with your ML workloads. Okay, so that's that. The first point is assuming that, say, you are running an on-premise cluster. On-premise, when I say on-premise, you have your pipeline completely on-premise, except, say, for the storage, which I'll explain a little while later in the next few slides. So basically, you have a compute. Maybe you have a couple of machines, or you have a small machine farm on premises, which, say, maybe powerful machines, maybe Threadripper machines, but then again, you are looking at serving a bigger market section and you just don't have the infrastructure to do it, so you decide to move over to the cloud. Okay, so that is the first point. It provides you with scalability and performance. So Databricks is capable of scaling automatically, so it uses Apache Spark, which is designed for distributed computing, allowing it to process large volumes of data quickly and efficiently. So this is all about distributed computing, right? So suppose there is a scenario where so Spark, as you are aware, will be it's basically a master slave kind of a configuration where the master will spawn executors on different workers, and it is going to in a distributed fashion, and that is where Spark shines. And of course, in the last session, if some of you who are there in the last session, you would see that we discussed about this different modes of how Spark can be used in a cluster. So Databricks uses its own cluster manager, so we will not be concerned about that here as to how Databricks is actually accomplishing that. But then again, the point here is to move from a local cluster, assuming that you're using a smaller cluster, or you are using Spark in a standalone mode on a single machine, and you just do not have the capacity on premises to expand to a larger cluster. So that is where the scalability part of Databricks comes into play. And then you have the point of collaboration and accessibility also. So Databricks will provide a collaborative workspace. So for example, for data scientists, engineers, and analysts, so suppose they are working in different geographic locations, okay, so they can collaborate in real time. And of course, this is facilitated through interactive notebooks that support multiple programming languages. Now, one interesting thing about Databricks is you can, in a single notebook, you can code in SQL, R, Python, Scala, and you can do all that stuff. Yeah. So these notebooks, the Databricks notebooks, are not the conventional notebooks like the Jupyter notebooks that you will be using on your local machine. Like you use a Jupyter, you download and install Jupyter, and you start using a Jupyter notebook. Databricks notebooks has greater capability, a little bit, of course, at a cost, right? And it allows users to switch languages as is needed within the same project. So this feature enhances productivity and reduces the conflict often associated with collaborative data projects. Of course, there are caveats, but this is the general thought. Yeah. Cost efficiency is something also, it's an advantage of using such pay-as-you-go platforms, but then again, you will have to use it judiciously, in the sense that though it is based on consumption, it's a consumption-based pricing model, but if you leave it on, you can incur a good amount of billing. So you have to be very careful of that. The cost has to be managed very carefully, but yes, in the long run, it is cost efficient. But this is debatable again. Okay, and definitely it provides you some advanced features for data science. So Databricks is particularly well suited for advanced analytics and machine learning applications. It provides built-in support for machine learning modules and tools, enabling data scientists to build, train, and deploy models more effectively. So overall, it's like you don't have anything. Suppose you do not have any compute on your on premises, or you have some compute on premises, you want to expand on it, you want faster, more powerful machines, and you want to reach out to the customers quickly without having to think about your own warehouses, employing personnel who are system admins, experts. They all incur cost, and they all incur a lot of management and headache. If you want to bypass that, then this is one of the solutions. Going to the next slide. Okay, so this is the existing on-premise setup. Okay, so existing in the sense we don't have it here, we don't have all of this here, but I'll just try to explain what is happening here. So imagine that you have, say, VMware running on your machine, or you could have a bare bones machine, you could have Kubernetes, you could have Hadoop Hive, or you could have Docker, okay, or a combination of these. So imagine on your cluster, so you have, as I said, you have a handful of machines on your cluster, and you have your PySpark running on all of these. You have PySpark running on any or all of these platforms. Yeah, this is the current scenario where we have everything on premises. Okay, and then of course, and this is communicating, but the storage, when I talk storage, so it is not being stored in the scenario that I have chosen is, the storage is not, of course, on premise. Okay, the storage is actually on Apache Iceberg, which is sitting on Azure only. Okay, so this part is already on Azure. Storage has already been on Azure, and we are communicating with that storage from a on-premise cluster, right? So this is the scenario. And then from there, we have, so Dremio is another platform which is used for visualization for mostly Iceberg. So we are using Dremio for visualization, and then we are using Power BI. So Dremio and Power BI is something that I will not talk about much here. I will most probably be showing you a dashboard, that's it. And this is just an overall, this is just an overview of what is really happening. So I'm not going to go deep in. So for that, I will be having an elaborate training on, okay? So this is the platform that we have currently. So anybody has any questions? These are plus signs, that is Spark plus, could be Spark plus a bare bones machine. This is some setup that you will use a lot, where you just set up a Jupyter notebook and you install PySpark and you start working on your bare bones machine with Spark in local mode. And this is another one where you work on Docker. So you download a Docker image which has a Jupyter notebook maybe, or and Spark, and you start working on it. You could have a Hadoop Hive. You could do it on a virtual machine. You could do it on Kubernetes, any or all. So your pipeline is basically running here. Okay, your compute is on the on your premises, and then it communicates with ADLS Gen 2 and Dremio and Power BI. So so this is the existing, say, on-prem UI and code. Okay, so in our case, this could be coming from a Docker container. This could be coming from a Kubernetes cluster, or anything for that matter. Okay, so say we have a Jupyter notebook with this kind of code that is running on our local cluster. So this is, say, it is running on a machine which is in my office. Okay, but then again, this is communicating with it is communicating with Azure in the cloud. It has its storage all in Apache Iceberg, but then again, your compute is on a local on-premise cluster. Okay, so it looks like this, where we have say, this is a Docker file, a Docker image which supports Jupyter and PySpark. Okay, so this is what it looks like, and we work here, and we run the pipeline. Yeah, so this is the existing on-premise setup. Yeah, now this is what, now when we are writing on-premise code, we are not using Databricks as such. Basically what happens is, when we have to use Spark, there are a lot of extra components that go into the particular Spark code. So those of you who are working in Databricks from the beginning with PySpark may not be knowing about the nitty-gritties of what goes in and what comes out, okay, of this. This is what we get. To begin with, in a Spark code, you have these import modules, and the middle one is the most important here. You have the Spark session initialization code, where you have to create the Spark session if you are not on Databricks. And then you have the code for data ingestion, transformation, and storage. Okay. So the objective of this particular migration here would be to make minimal changes to this particular script or minimal changes to this particular code base and run it on Databricks while taking maximum advantage of Databricks. Okay. It should not be like we barely managed to move it to Databricks and we are not really using the advantages that Databricks is providing us. Okay. So I'll talk more about that. So we will mostly focus on the middle section here. Okay. So we need to understand this very clearly. Spark, as it runs on Databricks, is exactly same as it runs on your local. The advantage of Databricks is that it hides a lot of the work from you so that you can start on Databricks with PySpark very easily. Okay. So setup and everything is done at the back end. But then again, when you are doing this kind of a migration, I will show you that it really does not go away. There are places where you need to add a lot of things, especially when you are using a remote kind of a storage, as I showed you. That is, we are using Iceberg, right? So that has to come somewhere, correct? So it is not that it is going anywhere, going away, and Databricks is intelligent enough to point to that particular Iceberg storage. Okay, moving on. I think you will be familiar if you have practiced PySpark on your local machine. This is how it is done. This is the standard format. Yeah. Now, this is what we do when we migrate to Databricks. Okay, this is what is being done. I'll spend some more time, maybe a little more time on this slide. We'll see, and probably I'll have some questions here also. So you had the import modules, you had the middle one which was a Spark session, and then you had the code for data ingestion, transformation, and storage, right? So in this kind of migration, what gets most affected is the Spark session initialization and other configurations. That's why you have the developer, as you can see, he's pushing that out of this block. Okay. And once this is being pushed out, the syntax conversion and everything is done manually. So there is a syntax conversion happening in the sense, all that you'll see it more in the training that I have. So you do a set conf for Spark and you set a different things in Spark, right? You set Java jars, and you set how the cluster should behave and what kind of executors you expect it to run on and things like that. Okay. So all of that has to come out, and that information doesn't get lost. That has to go into Databricks in some way, but not everything, but a significant amount of that information needs to go into Databricks. Okay. So it is not like you just start a Databricks notebook and hope that everything is going to be taken care of. So there is some amount of work that is involved here, and the syntax is converted, and then it is amended to the cluster configuration of the workspace along with compatible Iceberg library. So basically what is happening here is you take out the code from there, and you make changes. You start up the cluster, and then once the cluster starts up, you make changes to the cluster, and this arrow, when the arrow that goes back, is the final code that is moved to Databricks looks like this. Okay. So you only have the import modules and you have only code for data ingestion. The code in the middle just vanishes. It is not there. I would not say it is not there. There are a lot of caveats. Okay. For example, when you are setting up the cluster, for example, in Databricks for this particular, in my case, when I did the porting for on-premises, I could use the latest version of PySpark with the latest version of Scala. But then Databricks has some limitations where I really had to keep rolling back the version and go back to an older version which actually supported Iceberg. Okay, so there are such considerations that need to be taken care of. So this is not so straightforward. So all of that has to be taken care of. And then even the jars that get added to Spark for say, driver jars, for example, the driver for communicating between your script and your iceberg also needs to be added into the cluster. So that is not something that you can, skip. Okay. So everything is there. It's just how you manage it. Okay. And of course the reverse is also true. For example, suppose you have some script that you have on Databricks, and then you need to move it back to an on-premises setup. Of course, then again this process has to be reversed. Okay, all that configuration needs to be brought out and then converted and then moved to your code. So your code, again, when you bring it back to the premise, all that Spark session initialization either has to be here or somewhere else in some Spark configuration file, or when you do a Spark submit, it has to go there. Okay. So any questions on this one? So the question was, are the connections and dependencies changing? Connections don't really change because we use the same Java jar, the connector jar. Maybe it's a different version of it because Databricks will again have a different version of the jar to connect. So connection is there. What changes mostly? Okay, so what changes mostly, or something that you can completely drop when you're moving things to Databricks, is the cluster management configuration part of it, because Databricks has its own cluster manager. So we don't really need to tell it. For example, here, say we could use a Kubernetes cluster, or any, say you have Hadoop Hive cluster. So when you are configuring PySpark for those clusters in on-premise, you have to mention the driver and all that stuff, right? Here, you don't need to do that. It is taken care of internally. When you set up the cluster, you tell how many masters and executors you need to run, and that driver thing is taken care of automatically. Okay, so that is something that you can drop. Besides that, anything and everything that is being used is like it comes here. Okay, so we'll talk about that a little more here in the following slides. Okay, moving on. After migration, so say you have migrated now. So once you have migrated, what you saw previously becomes this. It's PySpark plus Databricks, and it's the same Iceberg and ADLS that you're using with the Data Lakehouse and Power BI as it is. Okay, so that part is the same. That part is intact. So now, instead of all of that, you have replaced it with Databricks. Okay, now, and the process is this, how we saw previously. Once this is replaced with Databricks, now the pipeline looks like this. This is also on Azure cloud. This Databricks cluster is also on this is also on Azure. This is the Databricks cluster itself. And then this part of the diagram actually stays the same, because Dremio was anyway communicating with the Iceberg previously. Even now it is communicating with the Iceberg as is. So there is no change in the good part is there is no change in this side. We only move the scripts. So this is what the deployment to Databricks looks like. So I will just briefly explain. So as you can see, this is now we have created a cluster. Okay, we have created a Databricks instance on Azure, and we have created a cluster. Now, in case of the code that we have on premise, okay, so let me just briefly show you the code. I don't expect you to understand anything, but then let me briefly show you the code which I had also shown in the last session, but nevertheless, let's do that. So you'll get an idea of what I'm changing here. Okay. Do you see this part? That is the configuration part. Okay, so here we had done a set master, we had done Spark jars packages, we had done Spark Kubernetes container image, okay, and so on and so forth. So much configuration. All of this, whatever I'm highlighting here, all of this is gone. Okay, so this is what you need to have when you have a local cluster on your premises. Okay, however, this part, though I have made some changes, this part is something that you need to have. That is the authentication part. The authentication part has to remain. Okay, that is, this authentication part has to go up onto the Databricks cluster. Again, this part is not needed. This Hadoop part is needed. This Hadoop and Hive part, yeah, this is needed because we are using the Iceberg tables. Okay, so from here to here, whatever you have, this part is has to be somehow conveyed to Databricks. And this you cannot convey. I mean, you could, but this you cannot convey directly in the code when you run it on Databricks. So there is a separate section in the cluster management console itself where you need to convert it in some format and then you need to put it. Okay. So that is what you need to do. This is all gone. This part is all gone. I have to define what kind of cluster it works on. So basically what happens is all of this is actually being taken care of by Databricks by itself. So we don't need to bother about this part. We have to put it in the GUI. This part has to go in some way. Okay. And then rest of the code stays exactly the same. No changes. This is the cluster here. So this is the cluster that you have. And you all know how to set up a Databricks cluster. I'm sure about it. Most of you. So what we have, so by the way, what you see here, the LTS version that I have chosen is an older version. Okay. There are much later versions. This is working on Spark 3.2.1 as you might notice, because Spark 3.5.0, which is the latest, somehow does not support Iceberg for whatever reason. So for me to make it work, I have rolled back to this version. In fact, on premises, it was running on a much later version. So as you can see, I've used a minimum number of workers as 1 and maximum as 2. So this substitutes for the cluster manager that I had set up manually. You saw the code. So this substitutes for the cluster manager that I had set up manually on my local machine. Okay. So this is taking care of in the cluster management here. That is, I'm sorry about that. I'm just touching the mouse pad and this is happening. Okay. So this is what is, so we do not need to know in this case, we do not need to know what kind of cluster manager Databricks is using, how it is actually distributing the work. Probably it is using a Hadoop Hive cluster. Probably it is using something else. We don't know. Okay. And we are not required to know. And that is a good and a bad thing. Okay. For example, for those of you who are actually working straight on Databricks on PySpark, you may not know how to set up a cluster in the local machine, and you would not know how the executors are actually working, because this makes it so easy for you. Okay. So now what happens is you see this libraries tab here. So here we have to set a configuration. Below this there is an advanced setup field where you actually need to put in some information. Now that information is basically the information about all your credentials, your keys, and what kind of catalog you're using, because you need to use a catalog, right? For when you are working on a kind of a NoSQL database, especially something like Delta tables or Iceberg, you need a catalog. So you have to tell this particular tell Databricks which kind of catalog you're using, and also all of that information actually goes in somewhere. It is not lost. And then in libraries here, this libraries that you find here, we have to put in the jar file, which acts as the link between this and the Iceberg tables. Now, for every version, for example, this is 10.4 LTS, as you can see, Apache Spark 3.2.1, the jar version changes. So you have to go to a particular location, go to a particular web page which actually talks about which jar version works for what. So you just cannot put in any jar version and expect it to work. So version matching is of paramount importance as far as Databricks is concerned, and it is a little bit more, I would say it's a little bit more difficult in this case, because Databricks is, as I saw, it is not so forgiving. Okay, you have greater control over your work if you are actually doing it on-prem. Though it is not, say, it may not be efficient, but it is definitely, you have greater control over your stuff, because here it actually forced me to stay on Spark 3.2.1, and I lost some benefits because of that. Okay, for example, I saw that there's a credentials file that I use. And in normal Python, if you just drop that file and add it as a module, it works. We know that, right? So you drop it as a module in the same folder and it just picks it up. It doesn't do the same here. Somehow it's not picked up. Okay, even though you have the file sitting here for this version. If I move to Spark 3.5.0, all of that works beautifully. But then your executors are going to fail, even though you are using everything right, because You roll back the version with the same code, it just starts working. So I am not sure what is going on here. Probably the support for Apache Iceberg for this particular Apache Iceberg for Databricks is not so well supported in the later versions. Now, the reason I stuck to Apache Iceberg as a storage is because that is something that people will select if they're going for a NoSQL database on premise. Okay, they'll usually not go for Delta Lake, because Delta Lake is again tied to the Databricks. People only created Delta Lake. Apache Iceberg seems to be a much more open standard which can be used, and it is more sophisticated than Delta Lake. It has more features. The only thing is you have to know the right drivers to use that in, because generally you would see if you're using Databricks, the tendency is actually to use Delta Lake, but there could be scenarios where somebody has a different NoSQL sitting somewhere. I have said that this is sitting in Azure ADLS Gen 2. This could also be sitting on AWS. You could have it anywhere. Okay. So is this clear? Is it understood? Okay. So I don't have many more slides. So moving on. So deployment to Databricks, again, as you can see, this is again notebook. Okay. And it's a Databricks notebook. I wouldn't call it a Jupyter notebook. It's like, it's much more. They have a lot of features added to that. So again, this is how it looks when you move the code. Okay, the middle part will not be there. This particular whole configuration that you saw here, this entire block will be gone. This entire block that you see here, this part will be there, and some more code will be added, but this part is completely absent from the code. Okay, and the code again starts from here. You may retain that block. If you want to migrate this code to Databricks as is, it will work. Just don't touch this block. Don't run this block when you can convert it into text or something like that. You can just convert it into a markdown and just leave it like that, because this should not be executed. But the script, if it goes up and sits in the workspace drive, this is going to work as is. Okay. Now the thing is, the downside, I wouldn't call it a downside, but then again, Databricks will have a lot of calls, like as dbutils is one very specific Databricks call that is not used here, because this is a migration from on-prem to the cloud, right? So people might want to start using dbutils, or they might want to start using a lot of such APIs that Databricks presents. The only thing is, once that happens, then it will become very difficult for you to migrate it back to on-premise if you need it. Okay. Right now, the script is in such a way that this can just be brought back and run on your local. So it can be seamlessly moved from your on-premise to the cloud with some changes in the cloud. But the moment you make some fundamental changes to the script, like using some calls to Databricks, then you get vendor locked. Okay. So as of now, the script is not using any specific Databricks APIs, which is a good thing and a bad thing, because that makes it very easy for you to do certain things. For example, at this point, it is not very easy to list the folders through code. Okay. For example, whatever I have in my Apache Iceberg, it is not possible to list it because I'm not using those libraries. Yeah. So that is one thing. So this is what it looks like after the migration has been done, and that's it. So this is just the tip of the iceberg yet again, because there is a session that I'll be having, and we'll be doing a deep dive into this migration, where actually we will look at how it was done. So we will look at the code, we will create the cluster, we will also go through some wrong paths. We will see. I was talking about the version problems that we were facing. There will be many other problems that we will be facing when we actually do the migration hands-on. So stay tuned, and I think this session is on the 23rd of August. So if you are interested to really know how this migration was done, that will be an interesting session. So any questions on this? Any questions, comments? Do you find this useful? what are the other things that we can add to this presentation or the next training that we are going to have. Okay, so that's it. So if you have any questions, please feel free to drop it in the chat, or you can personally come and ask me. I hope that the session that is coming up is going to be pretty interesting, where I am going to show you step by step as to how this migration was done. We'll create a cluster. We will move the code. We'll run some queries, okay, on the iceberg tables, and we'll show you the pitfalls also of what should not be done and what should be done. So this talk was intended for a wider audience, so I did not go too technical, too deep into what I really did. But then we have the capability right now to actually migrate scripts from either ways, like back and forth, like it can from on-prem to Databricks, or Databricks to on-prem, or if we have storage somewhere with NoSQL databases, communication with NoSQL databases is a competency that we have in-house. So this was also to showcase that. And then I'll see you again on the 23rd of August. So stay tuned for all the trainings that are coming up, and I'm hoping that they are going to be interesting. Thank you so much.